Hey guys, in this video, I'm going to go over questions 15, 16, and 17 from the 2014 AMC12B. This number 15, it reads when p equals the sum of k, ln k, from k equals 1 to 6, the number e to the p is an integer. What is the largest power of 2 that's a factor of e to the p? So the first step in this problem is to write out p as a sum, and we're going to get p equals 1 times ln 1 plus 2 times ln 2 up until 6 times ln 6. And there's a property of logs that we can use here that says if we have a log b, it equals to log of b to the a. And this is, you can use this for any base of log. In this case, our base is going to be e. So if we apply this, we're going to get p equals ln 1 to the 1 plus ln 2 to the 2 up until ln 6 to the 6. And there's another property of logs that we can use here. And it says that if we have log of a plus log of b is going to equal to log of a times b. And if we apply this, we're going to get p equals ln of 1 to the 1 times 2 to the 2 up to 6 to the 6. And if we raise e to the pth power, we're going to get e to the p equals 1 to the 1 times 2 to the 2 times 3 to the 3 times 4 to the 4 times 5 to the 5 times 6 to the 6. And if we, so now the problem just becomes how many factors of 2 are in e to the p. So 1 to the 1 obviously doesn't have any factors of 2. 3 to the 3 doesn't either, and 5 to the 5 also doesn't. So we're just looking at 2 to the 2, 4 to the 4, and 6 to the 6. 2 to the 2 has 2 factors of 2. 4 to the 4 is going to have 8 factors of 2. Because 4 itself has 2 factors of 2, and if you raise that to the 4th, we're going to have 8 factors of 2. And 6 to the 6 also has 6 factors of 2. So if we add these, we're going to get 16, and so our answer is going to be C. So this is question number 16. It reads, let p be a cubic polynomial with p of 0 equals k, p of 1 equals 2k, and p of negative 1 equals 3k. What is p of 2 plus p of negative 2? So the first thing we got to do in this problem is write p of x equals ax cubed plus bx squared plus cx plus d. And if we plug in p of 0 equals k, we're going to get d is equal to k. So basically in this equation, we can replace d with k. And the next thing we're going to do is plug in p of 1 equals 2k. And by doing that, we're going to get a plus b plus c plus k equals 2k. So a plus b plus c is going to be equal to k. And if we plug in p of negative 1 equals 3k, we're going to get negative a plus b minus c plus k equals 3k. And that's going to mean that negative a plus b minus c equals 2k. And notice now that if we add these two equations together, we're going to get 2b equals 3k. And that means that b equals 3 halves of k. And right now, we have to realize that if we have p of 2 plus p of negative 2, the a and c terms are going to cancel, because a times 2 cubed minus, or a times 2 cubed plus a times negative 2 cubed is going to be equal to 0. And similarly, if we have 2c, it's going to cancel with negative 2c. So right now, we can just solve for p of 2 plus p of negative 2 without actually solving for a and c. So p of 2 plus p of negative 2 is going to be equal to a times 2 cubed plus b times 2 squared plus c times 2 plus k plus a times negative 2 cubed plus b times negative 2 squared plus c times negative 2 plus k. These are obviously going to cancel, and we're just going to be left with 4b plus 4b, which is 8b plus k. And if we plug in b equals 3 halves k, we're going to get 12k plus k. Or, this is 2k. So we're going to have 12k plus 2k, which is 14k. And so our answer is going to be E. So this is question number 17. It says let p be the parabola with the equation y equals x squared, and let q equals 2014. There are real numbers r and s such that the line through q with slope m does not intersect p if and only if r is less than m is less than s. What is r plus s? So the first thing we're going to do in this equation is write out the equation of the line that goes through 2014 and has slope m. So using point slope form, that's going to be y minus 14 equals m times x minus 20. And the next step is a bit counterintuitive, but we're going to plug in x squared for y in order to get an equation to find the intersection points. And the reason we're going to do this is that since this equation is the one that gives you the intersection points, we're basically going to find the values where this equation has no solution. And if we move everything to one side, we're going to get x squared minus m times x minus 20 minus 14 is 0. And if we multiply this out, we're going to get x squared minus mx plus 20m minus 14 equals 0. And the way we're going to find the values that give no solution is we're going to set the discriminant equal to 0, or less than 0, sorry. So we're basically going to have m squared, or negative m squared, but that's just equal to m squared, minus 4 times 20m minus 14 is less than 0. And if we multiply this out, we're going to get m squared minus 80m plus 56 is less than 0. And since the coefficient of m squared is greater than 0, the parabola is going to look something like this. So the roots here are going to be r and s, and any value between them, which is m, is going to be negative. And so basically this negative value is going to be give a negative discriminant. And the values where it's equal to 0 are going to be r and s. So using Vietas, we can find the sum of r and s, the sum of the roots, and that's just going to be equal to negative 80 over 1, which is 80, so our answer is going to be E.